So finishing up. So here we go. We got this one here. We got a farmer who's got a flooded field. And so let's say we got the flooded field here. And the farmer standing on one side can take a measurement this way. So let's say that one's the 185 feet. Over to here. Let's say that's the 245. And we want to, and the angle between right here is 73. Again, this is not necessarily the scale. We want to find that width. So that's a nice quick triangle. You can see we don't have the angle on opposite side. This is all set up for the law of cosine. So that width, the opposite side squared, is the sum of the squares of the other two. So that's 185 and 245 squared minus 2 times their product times the cosine of the angle. And when we go ahead and solve that, because w equals the square root of all of that gobbledygook, you can just, again, even though I know I've like simplifying first, doing some of that multiplication, or that squaring, adding, and multiplying these, you don't have to. It just makes your calculating skills, or what you got to type in, a little bit nicer. But if you don't, you get the same thing, and we'll end up with a length of 260.3 units feet. Okay, and when I say the area, I think what trying to imagine that this was actually the triangle here. Okay, so how would we get the area of that triangle? Now, notice how we have the two sides and the included angle. In other words, the side angle side setup. And I know I had it drawn out there earlier, but if we draw it out here, so here is C. I'm going to put A up here though, and angle B here. So side B is here, side A is here. When we're looking at this formula, this here, if we would draw the height, because we know the area of the triangle is half base times height, there's the half, there's the base A. This height in this triangle is the sine of C is H over B, or H, the height, is B times the sine of C. Right there. You can always just recalculate, or just find that on these each time, but why keep redoing the work over and over again? It's done for you. So area is just half the product of the sides times the sine of the included angle. Type that in, which I already did. So 21,672 point goes 256 a whole bunch, so that would be 0.3 to the nearest tenth, and this is square feet. Usually we don't try to do a flooded area. Sometimes like a lot would be in a triangle. A piece of land, you get 2 fences on one side and something coming across diagonally. It's not easy to measure, so we could do it that way. Example 5. Again, I know we wrote this quickly. Basically, if you look at, we got a triangle here, 125, 130, 150. So if we try 1/2 base times the height, a regular, or even the other one, we'd have to use the law of sines, or cosine, sorry, to get it. Well, again, we can use this other formula. Now, using the law of cosines isn't terrible, but let's use this formula. So Heron's formula is the area of a triangle when we know the 3 sides. It's square root of s times s minus a, s minus b, s minus c. S is the semi-perimeter. Again, semi is the prefix for exactly half the perimeter. So when we go ahead and do this, so the semi-perimeter is half of 125, 130, 150, otherwise known as 202.5. So Heron's formula, and actually Heron's formula, because we'd have to use the law of cosines, comes from the law of cosines and a whole bunch of algebra in it. Not going to show you that. So square root of, again, reciting it as I'm writing it, semi-perimeter. And then these other three values is the difference between the semi-perimeter, the 202.5, and each of the three sides. So each of the three sides, semi-perimeter minus a side, semi-perimeter minus the last side. Again, could you simplify those, do that so there's just four numbers to multiply and come up? Yep, you can. Sometimes I do when it's like this, especially if they're nice numbers. I will go ahead and do that real quick, or put it all in the calculator as is, and you end up with an area of 7728. Yikes, what's that? .877 goes 7999. I guess that goes to tell you, if you're recording anything, don't have any other programs up in the background. Oops. I guess Candy Crush has that music. And then this is, of course, square feet. It's area. By the way, if you want to verify the units because you're used to it, semi-perimeter is adding feet up, so that's going to be feet. That'll be a foot, foot, foot. So feet times feet times feet times feet, or feet to the fourth. The square root of something to the fourth power is square feet. So the units work out all fine and dandy. Okay? Yeah, just a little different. Now, what about these last two? These last two look a little weird. Not really though. We've done this stuff, but this is sort of like in hiding. Two things going on. First of all, sinusoidal, sine curve. So this radio wave just has a sine curve, and we recognize the amplitude. And what about frequency? 150 hertz. Yeah, it's a cycle per second. That's what a hertz is. And no, that doesn't mean because it hurts your head. It's because it's from somebody's name. So we're going to try writing a sine curve for this. And since we're told nothing else, we don't have to worry about. We can adjust this to phase shift, all fine and dandy. Same thing with vertical shifts, all fine and dandy. We don't have to worry about that here. So when you're doing this on an oscilloscope thing to measure waves, that's what you do. You just adjust your wave so the phase shift is 0, and so is the vertical shift. So we can just say, okay, so we're going to have y equals amplitude sine, because it's a sinusoidal. And now what is our b? Well, thing is, this frequency, it's cycles per second, which is really just the reciprocal of the period, because the period is how long it takes for one cycle. So the period really can be thought of in terms of time as seconds per cycle. In other words, how long does it take to repeat? Whereas this is saying, how many do you get to repeat within 1 second or within whatever? So when you hear megahertz, gigahertz for your computer, that's how many cycles, how many actual things like calculations are getting done. That's the speed of it. Okay? So remember, we need our B value. What's our B value? Our B value before was the period, 2 pi divided by the period. Well, you can do it a couple different ways. You could say, well, if the frequency is 150, that means the period is 1 over 150. Or 2 pi divided by 1 over 150 gives you 300 pi. And because we're talking per second, we'll use t for this. The other way to look at it is, wait, isn't 2 pi over p really just another way of saying 2 pi times 1 over p? Or 2 pi times the frequency? You mean like 2 pi times 150, aka 300 pi? Ah, yes. So when we're talking about sine curves, sine waves, when we're graphing that, and I mentioned sines and phase shifts and all the waves, this is where it comes into play. This is also called harmonic motion. Yep, simple harmonic motion. Why? Like down here in example 7. Because it does deal with sound waves and the harmony, the sound of that. Simple, because it is simple, it's just one wave. We're not putting a wave inside of another wave or with multiple waves going on at the same time. That would be a non-simple harmonic or complex harmonic motion. So the actual radio waves that come through the radio to the car, that's not simple. There's waves built inside the waves. The waves inside carry that sound. The waves outside carry which ones you tune to. Yep, physics, gotta love it. Anyways, here's what we're gonna do. Put this to a sine curve. Here. So what's happening is we have this thing here. Got this weight that on a spring sits here, and we pull it down 2.5 inches. So now it's down to here, and then we release it. So it's going to go like that. So that 2.5 is our amplitude. Okay, so I equals 2.5 sine. What's B? Okay, frequency of 30. If we use this here, so our B is 2 pi times 30, 60 pi. T minus, now this time we do have a phase shift, because if we're starting down here, now we're doing a sine curve, so we can't just do opposite. So when do we get back to this point? How far does it take to go from a minimum back to that 0? In other words, one step, which was, you got it, a quarter of the period. So a quarter of the reciprocal of the frequency. So a quarter of 1/30th, 1/120th. So that's how you would treat those. Okay. Again, big pieces. This is just fitting this last two fitting sine curves. We do need to make sure you got the Heron's formula. That's really the only ones you really have to know, because you can always recreate this. But why recreate the wheel? That's done.